So I am John Lundgren. Yes, as he just said, I'm an agroecologist, entomologist. I worked for the USDA for about 11 years, and almost 1 year ago today, I quit, and we started our own research facility and demonstration farm, trying to promote regenerative farming practices, realizing that the farmers are really leading the charge in the innovation of our food production system, and that we have a lot to learn from that, and that the current infrastructure currently isn't well situated to provide the kind of information that we need to continue innovating that. So, what are we? This is Blue Dasher Farm. We have a research facility right there, as well as a 53-acre farm. We are in eastern South Dakota. You guys should pop on by sometime. Always welcome help. This is what I'm hoping to be a national network in regenerative agriculture. So we are looking at how we can use our food production systems to restore soil health, use biodiversity as a tool, and conserve our natural resource base while growing healthier food profitably. All right? That is regenerative ag. We reached out to farmers, beekeepers, support network around the world and said, if you believe in what's going on right now in this movement, consider supporting it. We crowdfunded a research facility through small donations. That's never happened before. All right? That's never happened before. But what this does is it gives us the opportunity to provide you the truth with no strings attached. And I couldn't do that as a federal scientist. All right? What do? We do cutting-edge scientific research to try to make the innovators continue to remove as many hurdles to you guys who are really trying to change things using agroecology on your own operations. Education. We are training not only the next generation of scientists, young graduate students through university programs, but also through development of an education curriculum for young farmers or beginning farmers that are interested in farming a little bit differently. And then finally, scientists love to get up and tell you all about, how you should be running your farm and what you should be doing out there. I do not believe. I quickly realized that that's maybe not the best source of information all the time. And so we believe that if we are to truly have credibility in what it is that we're talking about, we better be getting our hands dirty and we better be putting these concepts and principles into practice on our own. All right? And so that is who we are. That is what we're doing. Why? Why would I quit my cushy federal job? Because this planet is facing some serious challenges right now. All right? We are currently living through one of the worst mass extinction events that planet Earth has ever experienced. We are losing species at a rate that surpasses the dinosaur extinction. All right? We are losing. You guys have heard about the bee problem, right? You've heard, the bees are dying. This isn't a bee problem, folks. We're losing habitats, wetlands. We're draining them. Entire grasslands. Where'd the prairies go? Entire insect communities are diminishing within our agroecosystems. Birds, bats, bees, butterflies, terrestrial vertebrates. We are losing species at an alarming rate. Okay? What is the central problem? What is causing this? Agriculture is in part causing this. Currently on planet Earth, agriculture occupies 35% of the terrestrial land surface of our planet. Decisions being made on farms are contributing to climate changes, to pollution, to human health problems. We can tie these back to our food production systems. At the same time, if we recognize what is going on here, we also can use our food production to solve these problems. All right? This gives us an opportunity. Agroecosystems in the United States. What is this simplification that I'm talking about? Here's 4 of the top crops in the United States in terms of their land area. Corn currently occupies 5% of the terrestrial land surface of the continental United States. All right? Soybeans, 4.5%. Wheat, 2.5%. Alfalfa, 3%. Where once there was hundreds of plant species, we now have replaced those plant species and all of that biodiversity and all of the things that biodiversity does with a very simplified food production system. All right? 15% of our country is 4 plant species, all of which are maintained with chemical fertilizers, all of which are sprayed with glyphosate multiple times a year, all of which are genetically modified to resist pest proliferation, all of which are treated with neonicotinoid seed treatments unnecessarily. Did you hear me? Unnecessarily. If you are using insecticidal seed treatments on your crops, you are losing money. It is a bad business decision. The only way you can maintain simplified systems after you have taken out the biodiversity and all of the things that it does is you need to replace that biodiversity and all of the functions with a jug. You go down and you buy a jug and you put it on your field. And then as you use that jug, the biodiversity further declines. You've replaced it. And the only way that you can maintain the productivity of that system is with more jugs. That's an addiction. That's an addiction. Agrochemicals are an addiction. Who wins in an addiction scenario? Corn prices are the lowest they have been in 10 years. These are normal-sized girls. These are not midgets. They're short. But corn acres increased in 2016. Is this business-based? Who wins in an addiction scenario? It's not the addict. I can tell you that right now. It's the guy selling the drugs. Risk assessments. What are these drugs? Risk assessment is hard. I spent the last 20 years studying how can we assess the risk and the environmental costs and benefits of things like pesticides in our agroecosystems. Risk assessment is very difficult, okay? I've advised the EPA, European Food Safety, which is essentially the European EPA, run grant panels. Yes, we have some expertise in there. Some of the conclusions. Why is this so difficult? There are literally thousands of pesticide active ingredients that are currently registered in the United States right now. Thousands. That's the active ingredients. Each of them can be combined with any one of a number of hundreds of inactive ingredients that are almost entirely unregulated at this point. Sometimes having more of a biological effect on the target organism than the active ingredient does. It correlates to 20,000 potential pesticide formulas, each of which represents a unique risk assessment scenario. In cornfields, we have hundreds of species of just insects that are living in there, many of which we have no idea what their function is at this point. And each of these has its own group of hundreds of potential microbial symbionts, right? The complexity of the natural world is profound. Then, when you try to think 20,000 different pesticides to hundreds of different species, thinking about lethal, sublethal effects, and the fact that different environmental contexts completely change the risk scenario, risk assessment, and our ability to assess whether or not the chemistries that we're putting into our environment are safe becomes absolutely overwhelming. If you think because you see on the side of a jug that it's been approved, it is safe, that's what they said about DDT too. All right? Insecticides. With every decision that we make within our agroecosystems and how we're managing our food production systems, we have to weigh the costs and the benefits. Right now you're hearing a lot about the benefits, but the costs are incorrectly presented to you. All right? Neonicotinoid seed treatments are currently planted on about 13% of the land surface of the United States. 13%. It's an insurance policy, right? Your management of your pests, it's all in the bag. You don't have to think about anything. You just pay your $10 to $15 an acre for a seed treatment, and you put it out there, and you don't need to know anything about the pests, and you can just rest easy at night, right? There's no consequences. It's on the seed. As the seedling develops, these neonicotinoid seed treatments are taken up by the developing plant. Neonicotinoids on one corn seed, on 1 grain of corn, there is enough neonicotinoid to kill 360,000 honeybees. It is 5,000 to 10,000 times more toxic than DDT was. 13% of our land surface is planted to these things. Do they help? We now have data from soybeans, we have data from corn, I'm going to present to you data from sunflowers. But you could probably easily replace these slides with the other two crops. Okay? Sunflowers are an important crop in my part of the country, especially. We think of nectar and beneficial insects as loving those sunflower heads, right? The reality, though, is that the nectar a lot of the nectar on sunflowers and many other plants is actually kicked out through the leaves. They're called extrafloral nectaries. You can actually see this going on. If you lick the base of a leaf, it's sweet. Why is this? This is part of the plant's defense system. So what's happening is that the plant, when an herbivore comes along and munches on the leaf, it starts to kick out nectar out of its leaves. Who comes calling? Ants, lady beetles, predators, right? That eat the herbivore. So this is part of the plant's, it's like the old joke, okay, why are donut shops, why does nobody ever rob a donut shop? Because the donut shop gives free donuts to the cops, right? Same idea. Same idea, okay? But this is plugged right into the phloem system of the plant. And so as neonicotinoids are treated onto the seeds, they're taken up, and we could be potentially shooting ourselves in the foot by disabling the plant's defense system. All right, how do these neonicotinoids affect insect communities within these sunflower fields? Okay, first off, seed treatments. You cannot currently buy many commercial varieties without the seed treatment. We're working on that right now, okay? It's very difficult to find untreated seeds. They oftentimes won't even sell them. And when they do sell them, now the companies are charging a hardship fee. Have you heard of this? Several farmers have come to me. Well, we tried to order untreated seeds, but it was such a hardship for the company that they had to jack up the price on it relative to what they used to charge for untreated seeds. Give me a break. So, number one, herbivores. The neonic is supposed to control herbivores, right? We found that there was no significant effects. This is herbivores. This is over the season. either of those treated or untreated, we saw very similar herbivore populations. One of the key pests of sunflower is the red sunflower weevil in our area. We actually saw a bump in red sunflower seed weevil populations in the treated seeds, not the untreated seeds. Yields were exactly the same. We saw no herbivore control for these neonicotinoid seed treatments on sunflower. We saw no yield differences. We did find that the neonicotinoids were killing the predators that were living in the sunflower system. Here we see that over the season we saw a significant reduction in total predators as well as total ants. All right? Why is this? We think that's because it's kicking out those early season. That's when the extrafloral nectarines are particularly effective. Neonics. They're not controlling the pests. They're not improving yields. They're killing the predators of the pests. And you are being charged $10 to $15 an acre to do it. We've got data from corn. We've got data from soybeans. Just because somebody's got a new product, a new jug, doesn't mean you have to believe that this is going to save everything, all right? Question it. Question it. If you don't have to believe me, try it out on your own farm, right? Just try it out. What's really alarming is that the neonics aren't staying put. We wanted to, next to cornfields, this is my former postdoc, Chrissy Mogren, Dr. Chrissy Mogren, that's the back of her head, you'll see her in a minute. We wanted to offset, so the neonics are one of the reasons that the bees are in decline, okay? And we wanted to be able to offset, we thought if we feed the bees really well, can we offset the negative effects that the neonics are having on the bees, okay? So we planted these conservation strips next to our cornfields. We planted them on conventionally treated cornfields as well as organic cornfields because we wanted to control, right? For those of you who are interested in conservation strips, things like this, you know, you're going to find an awful lot of mixes out there. NRCS, Xerxes, Pheasants Forever, Game Fish and Parks, lots of different mixes. There isn't a lot of science behind any of them. Similarly, there's not a lot of science behind ours as well. Does it work? Yes, it works. Okay? What the idea is, though, when you're designing a conservation mix is to have a lot of different floral species out there. You want to have different flower colors, different flower sizes, different architectures of the plant. And then you also want them to flower at different times of the year so that there's always floral resources available. Okay, so these are some of the plants that we used in our conservation mixes. And then there's Chrissy. We collected honeybees, nectar, pollen, and honey from each of these different sites. And then we quantified the amount of clothianidin that was found in them, as well as the nutritional status of the bees. Leaf tissue. This is from the conservation mixes. These were never treated. Okay? All of them. All of them were contaminated with clothianidin. The LD50 for clothianidin to honeybees is 4 parts per billion. We see reproductive effects and navigational effects on the bees at 1 part per billion. If you have ever tried to harvest nectar from a flower in the field with a small glass capillary tube, it's a royal pain in the ass. So we let the bees do it for us. The bees are really good at this, right? So we let the bees go onto the flowers, and then we harvested up the bees, and then we yanked out their honey stomachs and collected their fresh nectar that they just collected from that flower. And we looked inside, and all of the nectars had clothianidin. Honey, pollen. Pollen that the bees were collecting had 10 times the LD50 for the honeybees. These were pollen from the conservation mixes. But what was most alarming is that in all of these, the organic farms had just as high a contamination level as the conventional farms. The neonics are not staying put, you guys. They're not staying put. They're in the water. They're in your food. They're everywhere. These are neurotoxins, and they're extremely effective at harming bees, as well as many other insects. We now have data from white-tailed deer. Vertebrates too, folks. Vertebrates too. Glycogen, lipids, proteins. This was in the corpses of the bees that we were collecting from each of these different fields, and this is how much Clothianidin we found in the bee bread, the pollen that they were collecting out there at each of these different field sites. We found that the nutritional status of the bees was compromised the more Clothianidin we found in the habitat. If you were to listen to a lot of the dialogue, it would become very clear that, it would become very cloudy what's going on with the bees. We just don't know. We just don't know. I mean, it could be any one of a number of things that's hurting the bees and the butterflies and the birds and all of these other species that we're losing. But guess what, folks? Starving, poisoned bees die. Okay? It's just that simple. It's just that simple. Step 1. If you have a pest problem in your field, that is your field telling you that something is out of whack. If insecticides were the answer to insect pests, we'd have kicked their asses 60 years ago. Why are we buying another jug to replace the last jug that stopped working? Why don't we solve the problem instead of reacting to the symptoms? Pests are a symptom. Let me give you an example. Corn, we give a lot of recommendations. You need to kill this pest, and this pest. If you don't, you're going to lose everything. Right? Buy this product. I realized in eastern South Dakota that we had been giving advice, but without a lot of actual data driving what was going on in terms of insect communities in those cornfields. So we set about solving that problem. We wanted to fill the data gap. We went across eastern South Dakota, where it's wet enough to grow a lot of corn. We sampled 53 different farms. And they spanned a range of different conditions, production conditions, from organic all the way up to highly, conventional farms. They needed to be more than 10 acres. These were actual fields. We wanted the insects to be there, and so we went with non-BT corn. We also didn't allow them we wanted cornfields that hadn't been treated with any insecticide. All right? We found that was impossible because most of the farms had at least a low level of the neonicotinoid seed treatment. Oftentimes the farmers didn't even know they were paying for it. Bioinventories are really important, so we set about trying to set one of these up. We looked at all of the bugs in these corn plants. And I'm just going to present the foliar data right now. So this is from the plant canopy. What did we find? We found 107, insect species. That's a lot. Oftentimes, it's argued that, agroecosystems are devoid of diversity, and that's really not true. We've actually identified now up to 380 different insect species from cornfields. Insect being anything with, less than 2 legs and more than 4 legs, all right? And that was just in the canopy. Of these, 7% of those species were the things whose names you'd recognize, like corn rootworms and corn leaf aphids and European corn borers, the scourges, right? On all 53 farms, none of them were at economically damaging levels. That means that farmers were paying hundreds of dollars per bag in seed technology fees to cure pest problems that weren't even there. That's a bad business decision, right? Of these species, 13% have some impact on corn. They're nibblers, things like that. They're not causing any problems, and usually it doesn't pay to manage them. What was the other 80% of species? Predators. Spiders, ants, lady beetles, minute pirate bugs, lacewings. We found 150,000 per acre out there. Dwayne Beck's place, you guys know Dwayne Beck? Have you heard? He's been here. He's been here. He's a regenerative farmer out near Pierre. He runs Dakota Lake Research Farm. He wanted to know what was going on his field with rootworms. So we injected 1,000 rootworm eggs per row foot, and nothing came out. Nothing came out. Planted the corn right into the rootworm eggs. He has more than 1 billion predators per acre on his farm in the soil. 1 billion, nothing. That's the biological resistance to pest proliferation. 107 species. It's overwhelming to think about. And to truly understand what's going on in such a complex biological community, we really had to turn to the social sciences, actually. We wanted to understand how this is a network, right? It's a web. Everything is connected within this web. We're connected to this thing, right? The insect pests are, the predators are, the cows are. It's all one network. But the social sciences are good at teasing out how information flows through the World Wide Web. They like to, lots of different tools for trying to understand this. We wanted to apply some of that network theory to biological systems. Perceptions of biological networks. Let's see. So our understanding of what a biological network comes from and how it works. I mean, think food webs, for an example. That's a form of a network. When you've got these, our understanding of these networks primarily comes from very simplified systems. A black plastic pot, right? And then you put a plant in there, and you stick a predator, and you stick an herbivore, and what happens, right? But that really ignores a lot of the complexity of a biological community. Here's a good example. So this is a food web, right? This is a food web from corn. We've got corn plants. We've got these cute little guys. These are European corn borers, right? We hate them. We hate them. They burrow into the stalks of your corn plants and reduce yield, make it more difficult to harvest, things like that. And once they're in there, I mean, it's really difficult to manage these things. That's where BT corn started, right? That's where they came from. This little alligator guy, this is a predator, this is a lady beetle larva. Little ladybugs, right? And then this little wasp, this is a wasp that does, most wasps do not sting people, they sting other insects. They lay their eggs inside of them. And so this wasp, actually, so she is a parasitoid of the European corn borer, Macrocentris is the name. And she finds a cornfield. And then she finds a corn stalk and her antennae start going, because that's how wasps and other insects smell things, right? And so she's tapping with her antennae, and then she's able to find in that corn stalk, without ever seeing it, she finds exactly where that European corn borer is, and she takes her stinger and she drives it through the corn stalk into the caterpillar and lays an egg that's eaten from the inside out. That's pretty cool. It's pretty cool stuff. Entomology is really interesting. This is going on in your cornfields on a regular basis. Okay, this is going on in your backyard. This is probably going on in your house. That kind of complexity. So what happens when you plug this out to the system, right? Oh, well, this one responds, and who knows, right? This is an actual corn network, species network. We took all of those 107 species and we linked them based on whether or not their abundances were statistically correlated. And based on those statistical correlations, we created a web. This is a lot of work. Each of the dots represents a species. So what happens, say this is one of your pests, you pluck that pest out of the system. It's connected to species that are connected to species that are connected to species. How can we manipulate these webs? You know, how many species can we lose before the whole thing collapses on itself? These are great questions. These are really important questions. What we learned by looking at these 50 farms is that our management decisions are driving whether or not we have corn pests. Each of these dots is a farm. On the x-axis we have pest density. On the y-axis we have species diversity in each of these farms. Corn farms that have high pest abundance have low species diversity. Corn farms that have a lot of species diversity do not have pests. Community evenness. This means that an even community is one that has equal numbers of all of the species in that community. Corn farms that have even communities where all of the species are in balance with each other do not have pests. Remember that hairball I just showed you? I pulled out all of the major components. This is a corn network, a species network from cornfields with very low pest abundance. Look at all the connections going on amongst those species. This is a cornfield with high pest abundance. All of the species interactions are gone. It's broken. It's broken. And of course it teases out statistically as well. What the point of this is, what kinds of decisions increase species diversity in a cornfield? Cover crops, no-till, interseeding, crop rotation. What kinds of decisions reduce species diversity in a cornfield? Insecticide use, tillage, things like this, herbicide use, fungicide use. Reduce insect diversity. When that insect diversity is gone, you now have pests. How do you manage your pests? You buy another jug, and another jug, and another jug. Solution to the problem. Just that simple, right? Just that simple. This is daunting, right? This is daunting. But the first step in this process is to admit that we have control over this. And it's actually quite empowering. And what's so empowering, it's not overwhelming, it's empowering. And why is it so? Because the farmers are leading the charge. You are not going to get this from many, concerted research operations right now. You're not going to get this message told to you. All right? Because the farmers are so far ahead in many ways of the researchers. We've got farmers, Dave Brandt is here at this meeting. They abandoned insecticides decades ago. All right? This is happening all over the country, that these guys are putting these practices and principles into play to increase their profitability and reduce their environmental footprint. Why? Is it because they hate insecticides and they hate Monsanto and so bring them down? No. It's a good business decision. That's the motivation. Soil health and conserving biodiversity makes a lot of economic sense. Here's a good example. We're just writing this up now. One of my graduate students, Claire Lacan, she's just finishing up, that she graduates this semester. She looked at 10 regenerative corn farms and 10 conventional corn farms. Best management practices across 4 states: North Dakota, South Dakota, Minnesota, and Nebraska. We went to the leaders in regenerative ag. We said, point us to your corn phase of your rotation. These regenerative guys are, a lot of times, no-till. A lot of times, invariably, they eliminated insecticides from their farms. They are always used cover crops. The conventional guys were investing in BT, neonicotinoid seed treatments, spraying herbicides multiple times, tilling oftentimes, whatever the regional, best management practices told them to do. Then we went out to these different pairs and we sampled all of the bugs. We did bioinventories. We sampled the soil characteristics. We sampled the profitability and the yields. What did we find? Insecticide-treated corn farms had 10 times more insect pests than regenerative. The insecticide-treated fields had 10 times the pests. You guys. The regenerative farms had fewer insect pests than the conventional farms. They had the same yield, so we can still feed the world, and they had twice the profitability because they weren't paying for all of the inputs. This was not me deciding on my research farm what treatments were going in there. This was farmer-defined science, okay? What are the principles that they are putting into these corn production systems? Number 1, they eliminate tillage. Tillage kills biology. The biology is the basis of your system. If you are killing the biology, then you have to replace it with a jug. Number 2, they always leave a living root in the soil. Bare soil is often dead soil. All right? More diversity is better than less. Where does this plant diversity come from? Field margins, interseeding, cover crops, rotations. We just found that simply by varying the rotation before your soybeans, we could reduce soybean aphids by 75%. That makes sense. That makes sense. And then finally, the last principle is that we have to start integrating livestock in cropland. That is one of the drivers of the biology in these systems. In addition to providing an additional revenue stream into your operation so that when crop prices go up and down and fluctuate, you're not left high and dry. The question isn't whether we can conserve species and produce our food. The question is what the hell's going to happen to us if we don't. Right? What's going to happen to us if we don't? We would not be here if I did not have such an enthusiastic team of young scientists, my lovely wife, and the support has been incredible. Truly, we crowdfunded much of the research that you guys saw here today. And science ain't cheap, I can tell you that. So many thanks to that. If you would like to learn more about what we're trying to do, go to our website. Ecdysis is the name of our nonprofit. This is a geeky entomology term for shedding the old skin. Metamorphosis. And then Blue Dasher Farm is the demonstration farm initiative. I do have a sign-up sheet on the piano. If you guys would like to get on our email list, you're more than welcome to do that. Visit our website. We're on Facebook. We're on Twitter. Like us. Follow us. We're trying to get new science out to you guys as regularly as we can.